Good evening.
Any doubt from last class? Okay. How many have solved assignment related to this part? Atif? Okay, no problem. So let's solve assignment related to that particular equation of traveling wave. First of all, try to solve on your own self. Try to solve this first part. In this equation, we have a wave traveling along positive x-axis, having amplitude 1 meter, wavelength 2 pi meter, and frequency 1 by pi hertz. So what would be equation of wave? According to general formula, equation of traveling wave will be A times sine kx. If it is going towards positive x-axis, then they will have negative sign with it, times omega t. Now put their values and simplify it. Now, how to calculate k? K is equals to 2 pi by lambda. And similarly, to find omega, it will be 2 pi multiplied by f. Just put their values and try to simplify this particular equation. All of you try to solve. Good, Atif. If you put lambda is equals to 2 pi and 2 pi will cancel out. So you will get k as 1. And if you put f equals to 1 upon pi, you will get omega equals to 2. Now, if you substitute in this part, a is 1, sine kx, k we have 1, minus omega, which is 2 times t. So the equation related to this part will be like this. So which is correct option, Riba? Yusuf, which is correct option? It will be option D. Abhinav, any doubt? Now, next question. A transverse wave is represented by y equals to a times sine omega t minus kx for what value of lambda? Wave velocity is equals to maximum particle velocity. I define you, wave velocity is equals to omega by k. If you put k to be 2 pi by lambda, so wave velocity will be this. And maximum particle velocity, it was omega times a. So just equate these two terms and you'll get the value of lambda for which these two velocity would get equal to each other. Try to solve. Good, Riba. Atif, just send your answer. On equating omega times lambda by 2 by equals to omega times a. Omega and omega will cancel out. So lambda will be equals to 2 pi times a. It means option C will be correct. Yusuf, any doubt?
No, sir.
In third question, we have a wave described by this 0.025 sine 10 pi x minus 2 pi t. So from this particular equation, we can say A is 0.25, 10 pi is nothing but k, and omega is 2 pi. And there is negative sign in between these two terms, and variable here is x. So we can say this wave is going towards positive x-axis. So direction of propagation will be positive x-axis. Next, we have to calculate its frequency. Omega is equals to 2 pi f. In this part, omega is 2 pi. So on equating, frequency will be 1 hertz. Now try to check in which option direction of propagation is positive x-axis and frequency is 1 hertz. Direction of propagation is positive x-axis. Atif. But in A, we have negative x-axis. Good, Riba. Good, Atif. So it will be option C. Rehab, is it clear?
Yes, sir.
Okay. Next question, question number 4. A transverse wave propagating along positive x-axis is represented by this. The speed of wave is. How to calculate velocity of wave? It will be omega by k. Omega is nothing but coefficient of t. So in this part, we have coefficient of t 4 pi. So we can say omega is equals to 4 pi, and coefficient of x is called k, angular wave number 0.5 pi. Just substitute these values in this part and try to find velocity of wave. Good, Atif. Good, Riba. Good, Rehab. Good, Yusuf. Abhinav, you got any answer? Umar, just send your answer. Omega, we have 4 pi and k is 0.5 pi. Pi and pi will cancel out. If we move this decimal, then we'll put 10. 4 into 10, 40 divided by 5, it will be 8 meters per second. So this is how we can calculate different term related to equation of traveling wave. Atif, any doubt?
No, sir.
Just 1 minute. This is another assignment related to a standing wave and beats. In first question, we have two sound waves having wavelength 5 meter and 5.5 meter. Lambda 1 is 5 meter and lambda 2 is 5.5 meter. Each propagating in a gas having velocity 330 meter per second. We have to calculate number of beats per second, which is also called beats frequency. In last class, I defined you how to calculate beats frequency. Is it nothing but difference of frequency of two wave. So first we have to calculate frequency related to each wave. According to the formula, velocity is equals to lambda into frequency. So frequency will be equals to velocity by lambda. Velocity we have 330 and lambda 5. So on dividing, you will get 66 hertz for first wave. Similarly, F2, which is velocity by lambda, velocity is 330 by lambda is 5.5. So if you divide these two terms, you will get 60 hertz. Now beats frequency is nothing but difference of frequency of two wave, that is F1 minus F2. Just simplify this. Good Yusuf, good Riba, good Atif. F1 we have 66, good Abhinav, and F2 we have 60. So if you take the difference of these two terms, you will get 6 hertz. Now question number 2. Two vibrating tuning fork produces progressive wave given by this. So in first, we have 500 pi as omega. So omega is equals to 500 pi equated to 2 pi f. So you'll get f1 equals to 250 hertz. Similarly, in second equation, we have 506 pi, that is omega is equals to, so equated to 2 pi f, so frequency will be 253 hertz. Use the above formula and try to calculate number of beats per minute. Atif, in this part, we have to calculate per minute. So multiply your answer by 60. Number of beats per second is equals to frequency difference of these two sources. So it will be 253 minus 250, that is 3 hertz. But in this part, we have to calculate per minute. It means you have to convert this particular time second into minute. So you must divide this particular expression by 1 by 60. then you'll get number of beats per minute. It will be 3 divided by 1 by 60. So it will be 3 into 60, that is 180. Riba, is it clear?
Yes, sir.
So it should be option B. Try to solve question number 3. Good, Riba. Atif, we have to check which is the most correct answer. In this part, we have taken two waves having different frequency. So first condition will be frequency should be different, but both should be start from the same point so that they will overlap on each other exactly. It means they should have same phase, or phase difference between two waves should be 0. In third part, you can say to overlap it properly so that you get maximum amplitude at louder point and minimum or 0 amplitude at the faint point. Amplitude of these two waves should be equal to each other. It means for beat, you should require different frequency, same amplitude, and same phase. Atif, is it clear?
Yes.
Okay. Question number 4. A wave y equals to 2 cos 10t minus 0.0080 x plus 0.18. So coefficient of t is called omega and coefficient of x is called k. So in this part, omega is equals to 10 radian per second, and k we have 0.008 radian per centimeter, since the measurement is in centimeter. So first we have to calculate phase difference between 2 points separated by a distance of 5 meters. So in last class, I defined you how to calculate phase difference. So delta phi equals to k times delta x. K we have 0.008 and delta we have 0.5 in meter. So just multiply it by 100 to convert into centimeter so that these two equations will have same unit. Just simplify it, you'll get your answer. Rehab, is it clear?
Yes, sir.
In second part, we have to calculate phase difference related with time. So delta phi equals to omega times delta t. Omega we have 10 and time difference we have 0.5 seconds. So you'll get 5 radian. Yusuf, any doubt?
No, sir.
Question number 5. First tell me, is it traveling wave or standing wave? Abhinav, is it equation of standing wave or traveling wave? Atif, is it standing wave or traveling wave? In this part, we have kx and omega t separately written with different function. So it will be equation of standing or stationary wave. Now from this part, if we compare with this equation of standing wave, you will say k equals to 2 pi by 6. Just equate it to 2 pi by lambda to find lambda. So lambda will be 6 centimeter since measurement is in centimeter. Coefficient of t is called omega, which is 160 pi equated to 2 pi f. So you'll get frequency is equals to 80 hertz. Now we have to calculate frequency, amplitude, and wavelength of original progressive wave. So wavelength is 6 centimeter, frequency is this one. How to calculate amplitude? Let me show you. This is equation of standing wave in which amplitude of resultant becomes twice as that of original wave. So if you have to calculate amplitude of original wave, so you must have to divide that amplitude by 2. So we may write 2a equals to 6 centimeter. So a is equals to 3 centimeter will be amplitude of actual wave. Yusuf, any doubt?
No, sir.
Question number 2, separation between two successive nodes. How to calculate separation between two successive nodes? Let me just show you. In this part, we have position of node and position of antinode at different part. So let's say this is one of the node and this is adjacent node. Now, if you have to calculate difference of these two terms, just subtract it, you'll get lambda by 2. It means each consecutive node get differ by lambda by 2. So we can say separation between node will be lambda by 2, and lambda we have calculated 6 centimeter, so it must be 3 centimeter. Riba, any doubt?
No, sir.
In third part, we have to calculate equation of original wave. According to the formula, y equals to a times sine omega t minus of kx. We have a 3 sine omega, we have 160 pi, and k 2 pi by 6 times x. So this will be your equation of original progressive wave. Yusuf, any doubt?
No, sir.
You may just write it down. Yusuf, done?
Yes.
There will be some related question from this chapter. You'll be asked to find a relation, a ratio between RMS velocity of gas and velocity of sound. We have calculated RMS velocity of gas in kinetic theory of gas. It was Vrms is equals to 3 times P by rho root under. Velocity of sound, according to Laplace correction, it will be root under gamma times P divided by rho. So we have to take ratio of these two velocity. So just divide these two terms. So Vrms divided by velocity of sound, it will be root under 3 divided by gamma. Rest of the term will get cancelled out. Atif, any doubt?
No, sir.
Just write it down. Yusuf, done?
1 minute. Sir. Answer.
Let me define you some question related to this part. Your first question will be, why transverse wave can travel through solids only but longitudinal wave can travel through all medium. Anyone want to explain? Riba, any idea? Let me just show you. This is the first part. In transverse wave, it simply depends upon elasticity in shape of the body. And we can define shape only for solids. Hence, it can travel only through solid. But in case of longitudinal wave, which depends upon beta, that is compressibility. And compressibility is defined for all different medium. Hence, longitudinal wave can travel through all medium. Atif, is it clear?
Yes, sir.
So your answer will be, as transverse wave depends upon elasticity in shape, but longitudinal wave depends upon compressibility. Of medium, and elasticity of shape defined for only solids, and compressibility of medium is defined for all medium. Hence, transverse wave can travel through all, longitudinal wave can travel through all medium, but transverse wave can travel through only solids. Next question will be in this part to define longitudinal wave, derive expression of velocity depending on beta and rho. Write Newton's assumption and Laplace correction. So for this type of question, you'll have to write all from the beginning of longitudinal wave till Laplace correction. Last formula, V is equals to gamma times P by rho root under. Abhinav, is it clear?
Yes, sir.
Next question will be, what do you mean by beats? And you'll be given two different equations on the basis of which you have to calculate beats frequency, like what we are doing above from the assignment part. So there will be numerical on this particular calculation of beats. Atif, any doubt?
No,
So when will be your final examination? Abhinav,
Yes, sir.
when is your final exam?
Sir, first we have preparatory from 23rd of February. After that finals date, they didn't give.
Okay, okay. Atif, in your school?
sir, it's not confirmed. As of now, they're saying it might start at February 14 to 17, that range.
Means your exam will start from 14th February.
No, sir, most likely 17, but it's not confirmed yet. It's subject to change.
Okay, okay, okay. So in the second term syllabus, we have mechanical properties of solids, fluids, thermal properties of matter, thermodynamics, kinetic theory of gas, and these two chapters, oscillation and waves. Okay. So start your preparation. For next class, just prepare two chapters, that is mechanical properties of solids and mechanical properties of fluids. Okay. I will give you paper and define you different question from that two chapter, according to which you'll be asked in your upcoming examination. Okay.
Sir,
Yes.
I don't know if I'll be able to join the next class.
Why?
Because I have exam. I have to prepare for it.
Okay.
It's on 9th.
So today is 3rd. I think next class will be on 5th, 7th or 8th, I think. Okay, no problem. Good luck for you. The rest of you, please prepare solids
Thank you,
and
sir.
fluid. We will start revision of that two part. Okay.
Yes, sir.
Okay, then
Yes.
let's stop here for today. We'll start in next class.
Okay, sir. Thank you, sir.
Sir,
Thank you.
Thank you, sir. Have a good night.
Thank you, sir.
Thank you.